So we discussed this position time graph in which the position is a constant, which shows that it represents a parked car or a stationary car or a person standing in the bus stand who is not moving. That's what is a position time graph parallel to the time axis represents. Let's go next. Can you see this is uniform motion in the body is moving from position x1 to x2. So the opposite side is x2 minus x1. By adjacent is t2 minus t1, and the slope of this tan theta will give you velocity. So velocity is displacement by time, which is x2 minus x1 by t2 minus t1. We call it as average velocity too. So let's go to this graph, which is a position time graph, which is a non-uniform motion. This represents uniform motion because it's covering equal distance in equal interval time, but there is this uniform motion. When I do a slope for this, you see that the velocity is increasing with time. Therefore, when I do a velocity time graph for this, I'll do a velocity which is linear, and when I do an acceleration time for this, I'll do an acceleration which is a constant. Okay, so that's what it is, and let's go. So then next is next that I discussed is this which where is then they have given a velocity time graph where velocity is constant. The previous one was a position time graph where the position was a constant, which represent a body which is stationary, whereas this is a velocity time graph where velocity is a constant. When velocity is constant, you cannot do a slope for this, so acceleration is 0. And area under this graph will give you the previous one, which is the displacement. So area under this, what is area? It's area DC into BC or whatever. Area of this ABCD, it can be a triangle, it can be a rectangle or a square, will give you the displacement. So let's go to next. Next thing that they have given is this uniform motion. It's not uniform motion, it's non-uniform motion. How do you know? This is a velocity time graph, and that itself is linear. Then the displacement time graph would have been a parabola. You know, when in the displacement time graph x is equal to t square, on differentiating it will become 2t, which is linear, dx by dt, and on differentiating this you get acceleration, which is d square x by dt square or dv by dt, which itself is becoming 2. So an acceleration time graph will become a constant. So from this, you know, this represents non-uniform motion, and the slope of this, which is v2 minus v1 by t2 minus t1, gives you acceleration, and that slope of velocity time graph gives you acceleration, and you know that will be a constant. Okay, so let's go to next. This gives you a velocity time graph. The area under this graph is a trapezium, half into s1 plus s2 into h. What is s1? This side. What is s2? Is this side. So you know this is v0 and this is v according to this, and what is this? It's time. So half into s1 plus s2, v plus v into time, and that will give you the area under the graph, which is a velocity time graph. So you get displacement. Therefore you get displacement. So let's go next. What else did I discuss today? Yeah, the velocity time graph. Oh, this is the derivation where graphically you can derive v is equal to u plus at, which is there in the PDF, and I've also included it in the previous video. So I'll go to this next graph where they have given my displacement time graph to be a parabola. Displacement time, it's non-uniform motion, and you do velocity for it, you know that the velocity is increasing linearly. So velocity time graph for this is like this. Acceleration time graph for this will be a constant, all that we know. And so displacement time graph slope will give you velocity, but this isn't. The velocity is increasing with time, so it's an acceleration. It represents acceleration or speeding up. Acceleration or speeding up. Whereas this is where the velocity is decreasing. Can you see the slope is decreasing with time? So this is a decelerating graph or speeding down graph. A speeding down, a position time graph for something which is decelerating is like this. A position time graph for something which is accelerating is like this. So you should know that. Okay, so let's go to next. This is a displacement time graph. Again, displacement distance, it's going to be same. The position does not change with time, and so then it's a parked car or non-moving car. Whereas in this is the distance is increasing linearly with time. It's uniform motion, and the distance time graph can be non-uniform motion for this. But here it's non-uniform motion. You have two categories. One is accelerating, another is decelerating, a speeding up or a speeding down. So then those are the various graphs. Look at this. They have given a distance time graph in which this is not possible. You can't in one single time you can't be in various positions. It's not possible. So let's go to next graph. Next graph that they gave is this. This is also not possible because the distance is decreasing with the increasing time. No, distance will always increase with increase in time. As time progresses, the distance will also increase. And this graph is also not possible. They've given a curve like this. At one time, you're in two different positions, two different distances. How is it possible? So to construct a line parallel to the y-axis, if this line is intersecting the curve at 2 points, that shows that it's not possible. So let's go to next graph. This is a displacement time graph where displacement is non-moving car. Again, displacement linear, which is a uniform motion. This is non-uniform motion. This represents speeding up. Okay. So what's next? And this represents speeding down and deceleration. And this is a displacement time graph in which you see there's a negative velocity. This is negative velocity graph. Because the slope itself, this is called negative slope, and with rises like that we call it as positive slope. So therefore this is definitely a negative slope. So the slope is velocity for a distance displacement time graph is velocity. The velocity is negative. So how do you represent velocity time graph? You represent in the negative direction because it's negative velocity. So what does this represent? When they give you a graph like this, you should understand that this can be compared in a real life with the position from A, the ball is coming to B and then moving past B to a point C. Supposing the baby is sitting here, the ball is coming towards the baby. The ball is coming towards the baby, move past the baby, and that's what this means. And all the directions are happening in negative y direction. So slope here also is negative, slope here also is negative, but it's a constant slope. So it's uniform velocity. The body is moving at the uniform velocity, but it's moving past the point B and going to C. That's what this represents in a displacement time graph. So let's go to next. The next thing that we discussed in class is these graphs. This is a velocity time graph. Velocity is constant, then the displacement should have been like this. The acceleration time graph will be 0. Yeah, so you know that this is moving with a constant velocity, the body is moving with a constant velocity, so acceleration is 0. And in this velocity time graph, you see that the velocity is increasing, which means the position time graph should have been an upward parabola like this, which you already know, and the acceleration time graph will be a constant. So you understood and interpreted all these graphs. So this is velocity increasing linearly, which means the xt graph is a parabola. And this represents a quadratic equation t square, x is equal to t square. This itself is parabolic, which means your xt graph, the previous position time graph, should have been a cubical equation. Because when you differentiate t cube, we get 3t square. Forget about this 3, but it ends up in a quadratic. If velocity is a quadratic, then the displacement time should have been cubical. Okay, and then the acceleration time would be linear. That understanding of all the three. So this is a deceleration. Velocity is here. If you do a slope, you get acceleration. Yeah, you get acceleration. It's accelerating. It's not decelerating. Accelerating. But the acceleration is lesser and lesser and lesser. Acceleration is lesser. Or in other words, decelerating. That means the velocity time graph, the acceleration time graph, it's decelerating. The velocity is decreasing with time. It means decelerating. Decelerating acceleration time graph is velocity is decreasing with time. So change in velocity is final velocity minus initial velocity will become negative, no? So acceleration time graph will be negative for this. Okay, so next is this velocity time graph. Can you see when you do a slope for this, you get acceleration. Slope itself is greater than 90, tan 120 or something, which is second quadrant angle, where it will be negative, tan will be negative. So the slope of velocity time graph will give you acceleration, and acceleration here is also negative. But the difference here is, here it's not constant, because the acceleration is going on decreasing. We can draw it like this. The acceleration is decreasing with time for this, I'm sorry. The slope is decreasing, so it's linear, but it's decreasing, Erangamukam or downhill. And for this, it's a constant. I made a mistake, I hope you're clear. So next is this velocity time graph. This similar graph which we saw for xt, where I said a ball is moving past the baby and going from O to A and A to B, or something like that. But that was a position time graph, but this is a velocity time graph, and this can be compared with a ball thrown up. A ball thrown up, the final velocity on the top will become 0. Here the velocity is becoming 0. So this represents, the downward graph represents upward journey of the ball. Because when you throw it up, you give it a velocity which may be 30 meters per second or whatever. So it starts with the maximum velocity, comes down with the velocity being 0, and upward journey of the ball is the downward journey on the graph. So this represents upward thrown ball, a ball thrown upward, and this represents ball thrown downward, because when a ball thrown upward is taken as positive velocity, a ball thrown downward should be taken as negative velocity, and this is having a negative velocity. So this graph represents a ball thrown up and coming down, very, very important. This is a velocity time graph. If it was a speed time graph, it will not be negative. So ball thrown up and a ball thrown down, ball coming down. It will be like this. Graph will come here like this if it's a speed time graph. So they are given this graph, velocity time graph. Area under this will give you displacement, which is area 1 minus area 2 plus area 3. Why minus area 2? Because this is displacement, it can be negative. They ask me distance, it's area 1 plus area 2 plus area 3. So that's the difference between displacement and distance. You should understand, it's given here. So let's go to next. This is nothing but the ball thrown up, and this represents ball thrown down, but speed time graph instead of velocity time. If it was velocity time, as I told you, it would have been like this and then coming down like this, which is velocity time. So what is this? This is a ball dropped on the ground from a certain height. The speed initially is 0. So the ball this is a downward journey. This always represents downward journey. Ball dropped down is, I think, now bouncing up. Ball falls, speed increases, and so the speed increases as the ball bounces back. So this graph represents the speed time graph of a ball dropped down and bouncing up. In a velocity time graph, how do we do this? So the ball which goes, this is the upward journey, which is the upward graph, which is the downward journey of the ball, and this is the upward journey, which will be a downward moment, but it has to start from the time here and will come like this. Yeah, I hope you understood, because this is velocity time. Generally they don't ask this, but if in case they ask. This is acceleration time graph, in which acceleration is a constant. This acceleration is increasing linearly, and they ask you to find area under this. You will get velocity. So area is area 1 minus area 2 plus area 3 will give me velocity, and area 1 plus area 2 plus area 3 will give me speed in acceleration time graph. Then is this, they've already given this sum is a beautiful sum. A body is starting from rest, accelerates for the first 5 seconds, accelerates. You are asked to find a displacement or find the total distance, you have to plot a velocity time graph, and area and velocity time graph will give you displacement. And so 0 to 5 seconds it's accelerating, so you have to draw it like this, increasing, it's uniformly. Acceleration time graph is a constant, then the velocity time graph will be increasing from 0 to 5. After that, from 5 to 7 seconds, can you see it moves 2 seconds with uniform velocity. Then after that, it takes 3 seconds to come to rest. It's going to decelerate. So velocity time graph is like this. So you complete this graph and find area of the triangle plus area of the rectangle plus area of this triangle will give you the total distance moved by the body. So look at this. From this graph you can interpret a lot, such as this is like we are monitoring a speed of the car. You see where is it going with the maximum acceleration. Slope of a speed time graph will give you acceleration. BC is where the slope is maximum. So BC is the time between 0.75 and 1 is when it's accelerating faster, maximum acceleration, or change in velocity is maximum. They're asking you to find the distance traveled by that in that second. Between that time is a trapezium, half into S1 plus S2 into H. What is S1? Is 20. What is S2? Is 50. Half into S1 20 plus 50 into height. Height is this 0.75 minus 1. The time difference between this is 0.25. Just find this answer and you get the value of the displacement or distance covered in that time. So that clarity you should have to understand the graph. So there are many graphs which have been given like this. So I'm sure you can try the sums on your own and understand and do it. So this is another velocity time graph where you see that this is positive acceleration. This has got negative acceleration and there's no acceleration. If I have to do a graph for this point, it's positive acceleration. From this zero acceleration. Then for this point, it's negative acceleration. So that's what they have given here, a positive, a 0 and a negative acceleration. And what is acceleration is the slope which is opposite by adjacent, in this case for this, which is 20 by 3 or whatever, 20 by 3 is the acceleration. So what is it? It's 20 by 3. What is 20 by 3? 6 3s, 7 3s are 21. No, it's closest to 7. Can you see? So like this you should plot the graph. Beautiful sum. This is all I discussed in the class today. Maybe one more sum. I think it's gone up. There's another sum which we dealt with here. This page, where they would say that a ball is getting thrown down and thrown up simultaneously. One ball is thrown down, another ball is thrown up. The ball which is thrown up has initial velocity 50 meter per second. The ball which is thrown down always have initial velocity 0. The gravity for a thrown down ball is positive. Gravity for a thrown down ball should be taken as, thrown up ball should be taken as negative, and use the formula S is equal to ut plus half at square for ball thrown down and a ball thrown up, and calculate the various positions at various times, because from time t is equal to 0 to time t is equal to 5, at t is 0, t is 1, t is 2, t is 3, t is 4, t is 5, you put s is equal to ut plus half at square and find the s value and then plot a graph. And in this you know that this is the downward journey of the ball and this is the upward journey, because in the upward journey you have at time t is equal to 1, it is 45. So 1 and 45. So this corresponds to upward journey and this corresponds to downward journey. Another way of finding is do a slope. The velocity is decreasing for an upward journey. So this slope is decreasing, that shows this is upward, and this velocity is increasing, and so this is downward. The another sum that we did is this, where OA represents a student A and PB represents a student B who is traveling. And you see the student B is already ahead by student A by 100. His position is not at origin. So the question such as who is ahead, A or B? You know that B is ahead. When it's starting time, B is ahead. Who has the greatest speed? Let's see. If I want to find the speed of B, I'll do a different color. I can find opposite by adjacent, which is opposite is 50 by adjacent is 2, 50 by 2 is 25. If I want to find the speed of A, I'll locate this point where the opposite is 150 by adjacent is 2 and write it as 75. You have to locate the place where you get clear values of opposite by adjacent. And the difference in the velocity is 75 minus 25, so you get 50, and that's what they're asking. So who is traveling with the greatest speed? Which has greatest slope? OA has the greatest speed because that's got a greatest slope. So look at this. In this graph, they're asking the distance traveled by the particle 0 to 10 seconds. Speed time graph is given. When you do the area under this graph, you get distance, which is half into base into height, half into base into height. Height is nothing but 12. Just substitute the value. You get 12 5 is 60 is the distance. Then average distance, average speed between this interval. Average speed is total distance by total time taken. Total distance is 60. Total time taken is, the time taken is 10. So you can say 6 meter per second is the average speed. You know, average velocity formula is x2 minus x1 by t2 minus t1. Instantaneous velocity is differentiation. I hope you are clear with all that. So now, time when the speed was maximum. Speed was maximum occurs at time t is equal to 5. You can see from the graph. Yeah. The time when the speed was minimum. Speed is minimum at, it's become 0 at 10 seconds and at 0 seconds. So that's the way you should answer these questions. These are the questions that we discussed today in class and recorded it. I'm sending it across to you.